Hello viewers, welcome to this lesson again of submath. Today we are going to talk about logarithm. Then we go straight away to the definition of a log. A log is the power of the base, or the way it is there. Logarithm of a number is the power to which a given base must be raised in order to obtain that number. This is what we mean. When I have a is equal to b power n, in logarithmic form, we write that one as the log of a base b is equal to the n. That's why we say that log of a number is the power of the base. So this a had b power n, so the power, when you bring in the logarithm, is going to be the log of a, and then this base here will remain as the base in the logarithm. For example, we have our 8, which is the same as 2 power 3 in index form. So when we try to write that statement in the logarithmic form, we have log of 8 base 2 that is equal to 3. That's why we say log of a number is the power of the base. Now, even here, we are going to first look at the laws governing logarithm. Then we do some simplification. Then thereafter, we do equations involving logs, and then an exercise at the end. So when we go to the laws, the first one there, we are having log of m base a plus log of n base a, that these ones we shall have to write one log to base a, then we multiply the m times n. An example there, we are having log of 7 base 3, then log of 5 base 3. So this one gives us log of 7 times 5 base 3. So when you look at the left hand side and the right hand side, is that the right hand side is somehow compressed compared to the left hand side. So the right hand side, we shall always say we are trying to write as a single logarithm. Then the left hand side, we shall say we are trying to expand that log. So either side, we are going to be using them in our coming examples. When we go to the second law, now the first and the second one, we are using them so much in O level, so they don't differ so much. Log of m base a minus log of n base a. This one gives us log of m minus log of m divided by n base a. So it can be written as that, or it can be written as that. An example there, we are having log of 4 base 6 minus log of 2 base 6. The bases are the same, so we can divide these ones here. So this is what we have there, that log of 4 divided by 2 base 6. When we go to the third one there, log of b power n base a, is that the power here is going to somersault and then comes there, which is that one there, as n times the log of b base n. An example, the 2 power 3. So the 3 is going to somersault and then comes there on the next step, which is the 3 times log of 2 base 2. Now we go to the next one. This one we are having log of m base m is equal to 1. So log of any number base to that number is always a 1. Log of a base a is a 1. Log of 1 million base 1 million is a 1. When we go to the next one, even this one we saw it in O level, that log of 1 to any base, that one is equal to a 0. For example, log of 1 base 5 is equal to a 0, and that one comes from 1 is equal to 5 to power a 0. Now the sixth one here, we are going to call it the change of base right there. An example is the log of 27 base 9. Now when we try to introduce or to change the base from 9 to a 3, we shall be having log of 27 base 3 divided by log of 9 base 3. When we go to the last one comes from the previous one, that is the change of base. When we have log of m base n, this one is going to be equal to 1 divided by log of n base m. An example is log of 2 base 4 is equal to, first I'm going to introduce the base of 2 in the upper part, then the downer part as here. Then we know that from this law here, we know that log of any number base that number is a 1. So log of 2 base 2 will be a 1 divided by log of 4 base 2. So we can easily interchange that one there quickly before going into, first of all, introducing the base that we want to change to. Now when we go to the examples, our number 1 is to evaluate the following. The part A there is log of 27 base 3. So what we are going to do here, we are going to prime decompose the 27 there on the next step, so that we get 3 power 3 as the 27. Now the power here is going to somersault there. Then we have 3 times the log of 3 base 3, and the whole of this is going to become a 1. So on the next step we shall be having 3 times a 1. Then 3 times a 1 is a 3 right there. When we go to part B, we are going to do the same thing. We are going to prime decompose the 64. 64 is the same as 2 power 6 as that. Then the 6 is going to somersault there. So that is going to be 6 times log of 2 base 2. Then log of 2 base 2 is going to become a 1. Then we multiply that 1 by a 6 to have the answer as a 6. When we go to part C, we are having log of 125 base 5 minus log of 50 base 5 plus log of 2 base 5. Now, since the bases are the same, what we are going to do, we are going to write the whole expression as a single logarithm. We are seeing here we are having an addition, so we shall need to multiply the 127 times the 2. Then the minus here implies that the 50 will divide the multiplication of these two here. So this is what we have on the next step here. Log of 125 times the 2 divided by 50. Now we are going to place our calculator and you see what we have as the result here. Or you try to simplify, reduce the 125 by the 50, and we see what comes about. Even the 2 can reduce the 50, then thereafter the answer reduces the 125. So the result of what is inside here, the bracket, is a 5. Then log of any number base to the same number will give us a 1. Then we take our answer as a 1. So we go to our part D. We are going to evaluate log of 8 base 4 plus log of 16 base 2. Now the bases here are different. You can see a 2, that's the base there. Then the 4, that's the base there. So here we are going to need to change one base into another. And we are going to change this base 4 to base 2 using the other law of change of bases. Hope you still remember it. So introducing here the base 2, we are having log of 8 base 2, then log of 4 base 2. Then we are going to prime decompose 8, and then we prime decompose the 4. Then the 16 has already been prime decomposed as the 2 power 4 there. So prime decomposing 8, we are having 2 power 3. Prime decomposing 4, we are having 2 squared. Now the next step, these figures are going to somersault there. Even this one is going to multiply there, and even that one is going to come and multiply there. So that is the 3 times log of 2 base 2 divided by the 2 times log of 2 base 2, then plus the 4 times the log of 2 base 2. Now when you look at this value here and that one there, you can see that they are the same. It's like someone having 3n divided by 2n. So the n will cancel out with the n. Therefore here the log of 2 base 2 will cancel out with the log of 2 base 2. Or we just simply say that the log of 2 base 2 condenses to a 1. So that will be 3 times 1 divided by 2 times 1 plus 4 times a 1. To have the 3 all over 2 plus a 4. So this one here is a fraction. You know how to add fractions. The base here is a 1, and now the LCM of 2 and the 1 is a 2. So we are going to multiply there the 2 and even there the 2 to have 3 plus 8 divided by 2. Then when you add in the numerator, we'll have 11 all over a 2. When we go to part E, we are still evaluating, and what we are going to evaluate now is the a half times the log of 25 base 10 minus the 2 log x base 10 plus log of 2x squared base 10. Now even here the bases are the same, base 10, base 10, and base 10 there. So what we do, we are going to write the whole expression as a single log, that is taking now this power half back there, taking back this 2 as the power now of x there. Then since we have subtraction and an addition, we shall need to multiply the 2x squared there with the result of here, then divide by the result of that one there. Then the next step is try to simplify this one here. The 25 power half is like the square root of 25, or here the 25 is the same as 5 power 2, then times the power half, then we get that one as a 5, or someone can just say that is the square root of 25, which is just a 5. Now we are going to multiply this 5 times the 2x squared, then lastly divide by the x squared there, which is this. Then we are going to see what we have as the result. First of all, the x squared will cancel with the x squared, leaving 5 to multiply the 2, and the multiplication there we shall be having a 10, and we said that log of any number to base the same number, that one condenses to a 1 or becomes a 1. Part F, log of 216 plus log of 64 base 2 divide by log of 243 base 3 minus log of 0.1 base 10. Now when you look at that figure, is somehow related to the base. The 64 is somehow related to base 2. The 243 is somehow related to the base, which is a 3. The 0.1 is somehow related to the base 10. So when you try to express the 216 in terms of 6, that is when we draw the ladder method, then you try to divide the 216 by 6, you get 36. Then again 36 divided by 6, you have a 6. Then again 6 divided by 6, you have a 1. And lastly the 216 becomes a 6 power 3. So this is what we are going to be substituting there. Then we do the same thing here, we do the same thing there. Then as for the 0.1, this one's just the same as 1 divided by 10, but remember in index form this 10 in the denominator is power 1, so we shall rewrite the 0.1 as the 10 power negative 1. Remember the index form when we wanted to write this denominator in the numerator, so we had to change the sign of the power. We are having that log of 6 power 3 base 6, log of 2 power 6 base 2, then log of 3 power 5 base 3, and lastly log of 10 power negative 1 base 10. So we are going to make these numbers come there, the next step. Even that one there. We said that we have a law which tells us that the whole of that becomes a 1, that one becomes a 1, that one becomes a 1, the whole of that also becomes a 1. So we shall be left with a 3 plus 6 divided by the 5 plus a 1. Remember here previously we had a negative times a negative, and those ones we said they will become positives. We get the answer as 9 all over 6. 9 all over 6, when you reduce it, we are having 3 all over 2. Then when we go to number 2, given that a is equal to log of x times y squared base x, and b is equal to log of x power 3 times y power negative 2 base x, find the value of a plus b. They're telling us to add this and that, which is this on the first step is the first substitution. The a is the whole of that and the b is the whole of that. Then we are going to look at ways of simplifying those two expressions. Since there is a positive here and the bases are the same, we are going to just multiply the whole of this times the whole of that base 2x. So when we multiply, this is what we have there. Then we go back to the index form, the x there and the x there, we shall add the powers. The y here and the y there, we shall add the powers, which is this here on the next step. So when you add the powers, the power of x is a 4, the power of y becomes a 0. So any number power 0 is a 1 from the indices, which is that. Then we remain with log of x having a power of 4. Then this 4 is going to somersault to there on the next step. And we said that the whole of this is going to become a 1. So 4 times a 1, we shall have the answer as a 4. We go to number 3, simplify log of 9 base 4, log of 21 base 4, log of 7 base 4. When you look at the bases, they are the same, base 4, base 4, base 4. Then we have an addition there, then a subtraction there. So we are going to multiply 9 times 21, then divide by the 7 on the next step. So when we try to compute this, we get log of 27 base 4. Then we try to simplify the 27. Remember, when you prime decompose, we are having 3 power 3. Then the 3 will somersault to have 3 times log of 3 base 4 as that. So from there, we cannot simplify any further. So we leave the expression just like that. We were not told to evaluate, we were just told to simplify. We go to number 4. If a is equal to log of x, b is equal to log of y, c is equal to log of z, expressed in terms of a, b, c, the first part is log of x squared times y cubed divided by the root of z. Now here, where you don't see a base there, in O level they used to tell us take the base as base 10. Even here we are going to maintain that. Where you don't see any base given, we take that logarithm to be having a base of 10. So we are going now to disintegrate the whole of this. Remember, we have been writing them as single logarithm. Now it is a block which we are going to try to dismantle. The multiplication, remember, we were adding 2 logarithms. Then the division, Remember, we were dividing the log of whatever is down here. So the next step, like I've said, the multiplication implied that we are adding log of x squared to log of y power 3. Then the division implied that we are subtracting log of the value which was down. Now, on the next step, we are going to make these ones somersault there, the figures, and the root. Remember, in index form, the root was power a half. Also, the power half will somersault there. So the next step, they have first converted the root into the power half. Then on the next step, that's where we are going to make the values to somersault. So the 2 comes there, the 3 comes there, and then the half comes there. Now, here I can go back to my question that the log of x, where I see the log of x, I'm going to put a. Where I see log of y, I'm going to put b. Where I see log of z, I'm going to put a c. So that one's going to be a 2 times, you see the log of x, I'm substituting it with a multiplication of a. The same applies to log of y. The same applies to log of z. So these ones, when we multiply them, they remain the way they are. 2a plus 3b, then minus a half c. So we leave our answer like that, because we have been told to express the logarithm in terms of a, b, and a c. So number 4, part B, we are told also to express that log in terms of a, b, and then a c. It's the same thing. The steps which we took in part A, they are the steps we are going to take in this part also. The division means we were having a minus of 2 logarithms, that is log of 1 minus log of x squared y squared. Now this one here, log of 1 base 10, we said there is some law that said you write that one as a 0, so we are going to substitute it as a 0. Then we also dismantle this one here, because there is a multiplication there, implies that some 2 logarithms were adding each other, which is this here, log of x squared plus log of y squared. So the 2 somersaults here and also the 2 somersaults there. Then I substitute the log of x with the a, substitute log of y with the b. Then the other one, log of 1 base 10, I already said we are going to call it a 0. Then finally, we write the answer as the negative 2a minus the 2b. This 0 just disappears. Then the minus opens the bracket to have a negative 2a and a negative 2b. When we go to number 5, if log of 2 base 7 is equal to 0.356 and log of 3 base 7 is equal to 0.566, find the value of 2 log of 7 all over 15 base 7 plus log of 25 divided by 12 base 7 minus 2 log of 7 divided by 3 base 7. The bases are the same. What we do is to first express those 3 logarithms as a single log. Then from the answer, we try to simplify into the log of 2 base 7 log of 3 base 7. So the first step, we're going to make the 2 come back here and also that 2 to come back there, which is that. Then we are going to make the power square whatever is inside the bracket there. Also the 2, we're going to square them. So the 7 squared becomes the 49, the 15 squared becomes the 225, and here the 7 squared becomes 49, the 3 squared becomes a 9. Now, since we are having an addition and a subtraction there, we are going to multiply this times that, then we divide the whole thing by this answer here. We are having that one there, divide by the 49, divide by 9. Now we can exchange this sign to become a multiplication sign, and remember we used to take a reciprocal of this one here. So we shall be having a 9, a multiplication of 9 all over the 49 there. So we multiply everything and we see the result that we are getting. So we get log of 1 divided by 12 base 7 there. Now this 12, there is a 2 and a 3 which is embedded there. The 12 is 4 times 3. This 4 is the same as 2 squared. We are going to be writing the 12 as the 2 squared times the 3 here on the next step. Now before we go to substituting a 12 by a 2 squared times the 3 power 1, we can first dismantle this one here. Because it is a division, that means that log of 1 was subtracting the log of 12, which is that one there. Then we substitute this one. Then later on we shall see that this one here, we are going to be having a 0. So the 0 minus substituting the 12 with a 4 times a 3. Then later on, the multiplication there also implies that these two logarithms were adding each other. So log of 4 plus the log of 3 base 7. Then now the 4, I said the 4 is the same as 2 squared. Then the 2 comes there, which is this. Then we also open the bracket to have a minus 2 log 2 base 7 and also a minus log of 3 base 7. Now we are going to substitute this one as given in the question, which is there. Then we also substitute this one here as given in the question, that one. So it's going to be a 2 times the 0.356 minus the 0.566. When you multiply this, we are having that. Then when you add the 2, we are having a negative 1.278. Number 6, find the value of log of 12 base 7. Now this one here, we can change the base right away. That is introducing the base that we know, or the base we can get on our calculator very fast. Or the calculator can give us log of any number to base 10. That is why we are using the base 10. We are changing the base of 7 to base 10, both in the numerator and in the denominator. Then you place your calc, you get the answer there as that value there. Then we round off the answer to 4 decimal places as the 1.2770. Rounding off to 4 decimal places, I'm having my 4 decimal places there, but this 8 is going to make an addition of 1, and the 1 here will make the 6 to become a 7 for it to remain a 0. That is why I'm having the 1.2770. Another way is to go step by step, but this alternative is somehow longer than the first one. Here we let the value we are going to find to be equal to an unknown. Then we use the definition of logarithm. Then we try to express it in an index form. That is, the 7 will be powered m to give us the 12, which is that there. Then from there, the next step, we are going to introduce log base 10 both sides. I've said we are introducing log base 10 because it's the one that is on our calculators. So introducing log base 10 both sides of the equation, the power here of m is going to somersault to there on the next step, which is that. Then I can place this one on the calculator and that one on the calc, or dividing log of 7 base 10 both sides. So when I divide it both sides, I'm having m as log of 12 base 10 divided by log of 7 base 10. So this step is the step you are seeing there. Then we place our calculator to have the answer there, and approximating the answer to 4 decimal places, we get that answer. Number 7, evaluate log of 4 base 8. So even here, we are going to change the base to base 2. We are having log of 4 base 2 divided by log of 8 base 2. Then simplifying the 4 and the 8. The 4 is the same as 2 squared. The 8 is the same as 2 power 3. Then the 2 will somersault there and the 3 will somersault there to have the 2 times log of 2 base 2 divided by 3 times log of 2 base 2. This one will become a 1 and also that one will become a 1 to have the answer as 2 divided by 3. Then we go to the equations involving logarithm. So these equations, we are going to see how we employ different logarithmic laws to evaluate or to find the values of the unknowns. Example 1, solve the following equations. The first one there is 5 times log of x base 10 plus log of 5 base 10 is equal to a 1 plus the 2 log of 4 base 10. Now, we can see that the bases are 10 on these 3 terms here, but one term there doesn't have a logarithm, so we are going to introduce a log. Remember where we said that log of any number base to that number, that it is equal to 1. So since the other logarithms, they are to base 10. Even this one, we are going to be calling it log of 10 base 10. Then we are going to put back that one where it came from, even that one where it came from, which is that. Then the next thing on the left hand side, since we have a positive, we are going to multiply this times that. Then even on the right hand side, we are going to multiply this times that. Now, when you look at both sides of the equation, we are having a single logarithm there, and each logarithm is to base 10, base 10. So we are going to equate whatever is here since both expressions are equal to each other. So the x power 5 is equal to the 160. Then we divide both sides by 5 to have x power 5 as 32. Then we take the 50 root both sides of the equation to have the x value as a 2. When you look at part B, there is this 2 here which doesn't have log base 3. So the same way, we are going to say that the 2 is being multiplied by a 1, but the 1 is now log of 3 base 3, which is that there, the 2 times the 1, and in the next step, we make that 1 to become a 3 base 3. Now on the right hand side of the equation, we are having a minus there. So the minus implies that this will be divided by that on the next step, which is that. Then this 2 is going to somersault there, like that. Then since we are having log base 3 both sides, we are going to say that that one there is equivalent to that. Then from there, we are going to find ways of simplifying this expression. The 9 is all over a 1. Then we are going to cross multiply. When we cross multiply, the 9 multiplies the 3x minus 11. When we open the bracket here, the 9 multiplies the 3x, and also the 9 multiplies the minus 11 to have the 27x minus the 99. We collect like terms, we can bring the 2 this other side of the equation. The minus 99, we also take it the other side of the equation. It is minus, therefore when it crosses equal sign, it's going to become a positive. So that is the 1 plus the 99. The 2x this side was a positive. Then when we take it the other side, it's going to become a minus, just like that. So on the right hand side of the equation, we shall be having the 25x. Then the left hand side, we shall be having 100. So we can divide the 25 both sides of the equation to have the value of x as a 4 right there. So when we go to part C, we are still solving for the unknown which is in the equation. Now when you look at the whole of that equation, it is only 24 which does not have a log base 2. So now what we are going to do, we have two ways here of doing this number, but the first one, since we are having an addition there, we are going to multiply this times that to have log of m power 6 base 2 is equal to 24. Then you make the 24 to have a log base 2 on the right hand side. then you continue solving. Or the one we are going to use here now is we are going to make the 2 somersault there, then the 3 also somersault there, which is that. Then now this, the whole of log of m base 2 is like I'm having y plus 2y plus 3y. So when I add, I'll be having 6y, which is the 6 log m base 2, which is equal to 24. Then I first divide both sides by the 6. Then I have log of m base 2 as a 4. Then lastly, now I use the definition of logarithm that log of a number is the power of the base. So the m is going to be 2 power 4. Then the 2 power 4 becomes the 16. So here you can try out the other method that I've told you about and see if we are getting the same answer. Our part D, we are having 0.3 power n is equal to 0.8 power n plus 7. So when you look at the bases, they are not the same, but also the powers are not the same. So here we apply log to a base that we know or the base that we can get on our calculator. So applying log base 10 both sides, we are having that. Then now the powers are going to somersault to there. The whole of this power is going to somersault to there. To have n times log of 0.3 base 10 is equal to n plus 7 into log of 0.8 base 10. So I can get this one on my calculator, substitute, and also get that one on my calculator and substitute. But before I do that one there, I'm going to first simplify. That is opening this bracket here. The n is going to multiply that one, and also the 7 is going to multiply that, which is this and that. Now I'm going to take the whole of this, the other side of the equation, to have n log of 0.3 base 10 minus n log of 0.8 base 10 is equal to 7 log of 0.8 base 10. Now when you look at the left hand side of the equation, the n is common, so I'm going to factor it out. So when I factor it out, I'll be left with log of 0.3 minus log of 0.3. So the minus implies that I can write the two expressions as a single log by getting the 0.3 divided by the 0.8 as here. Then now I divide the 0.3 by the 0.8 to have 0.375. Then lastly, I divide this whole expression both sides of the equation, which is that. Then lastly, I get the answer as that one there. Then I round it off to 4 decimal places as the 1.595. This example 2 is going to help us show us how we used to drop those bases. So solve for p in 2 power. P is equal to 1 all over 8. The 8 is the same as 2 power 3. The 1 all over 2 power 3 is the same as 2 power negative 3. Hope you remember that. So I go straight to that step. Then here we apply log base 2 both sides of the equation. So when I apply it, the power of p is going to somersault to there, the power of negative 3 is going to somersault there. So we shall be having the p times this one, we said it will condense to a 1, is equal to negative 3 times that one, we said it will condense to a 1, to have the p times 1, which is p, is equal to the negative 3 times 1, which is a 3. So I wanted to show you that we apply log to the base of the indices on both sides, then the powers somersault, and finally we state the answer like that. So number three, if 3 plus log of x base 10 is equal to 2 log of y base 10, express x in terms of y. So we are going to find ways of writing the left hand side of the equation as a single log there, and also this side we are going to make the 2 come back there, such that even on the right hand side we have a single logarithm there. So the 3 on the left hand side is being multiplied by a 1. The 1 is log of 10 base 10. So I've talked about this one there. Then also substituting the 1 with log of 10 base 10. Then the 3 is going to come back there, which is that. Then since it is an addition, on the left hand side we have two expressions there, so we are going to write them as a single log. So an addition implies that this is going to multiply that, so which is that. Then we can drop the logarithm there. The 1000 times x is equivalent to y squared. Then I divide both sides by 1000 to have x as y squared divided by 1000. Number 4, show that log of x base 8 is equal to 2 all over 3 log of x base 4. Now, on the right hand side, we are having a base 4 there. And on the left hand side we are having a base 8 there. That means we are going to find ways of introducing another base on the left hand side such that we can get a base of 4 on the right hand side. So while showing that the left hand side is equal to the right hand side, let us use the left hand side. So when we introduce log base 4 here, we saw that rule, which was the change of base. Then we are going to evaluate this, because when you look at the right hand side, we are not seeing there log of 8 base 4. So the log of 8 base 4, we also apply the change of base there, and that is the base 2, because we can easily evaluate the whole expression of log of 8 base 4 using the change of base 2. So applying the base 2, the numerator here we shall see that we have a 3. Then also the denominator here we shall see that we have a 2. You can go back to the previous examples. We did some number which was to evaluate the log of 8 base 4 to have this. So I'm going to get this, and I come back and I substitute it there on the next step. My log of x base 8 is now equal to log of x base 4, then divide by the 3, divide by 2. Now, when you try to simplify this one here, we shall be having the 2 all over 3 times log of x base 4. And this one here is the right hand side of the equation, and then we have showed it as the way they wanted it. Number 5, solve the following equations. Part A, log of x base 5 plus log of 5 base x is equal to 2.5. Now, these parts here we are going to look at now, they are going to lead us to quadratic equations. The bases are not the same when you try to look at the expression on the left hand side of the equation. This one has base x, the other one has base 5. So what we do, we change this one to base 5 by using the last law of logarithm that we looked at. So this one becomes 1 all over the log of x base 5. You can see that this one here is the same as that one. And the next step, we are going to say we let the whole thing to become to one unknown, which we can easily deal with and simplify later on to get the value of x. So I let m to be equal to the log of x base 5. So where there has been log of x base 5, I'm going to substitute it with the m. So that is the m plus 1 over m is equal to 2.5. Now, we are having a fraction of m in the denominator. Then the rest here are having the denominators as 1. So we get the LCM of the denominators, then we multiply it throughout just to eliminate the denominators. So the LCM is m. So the first part there times m, the next one there times m, and even the other side of the equation times m. So the result, we are having m squared plus 1 is equal to 2.5. Then I bring this one, the other side of the equation, to have m squared minus 2.5m plus 1 is equal to a 0. This point here shows that this one is like the same as 25 all over 10. So I'm also going to multiply through by the 10 to have the 10m squared minus the 25m plus the 10 is equal to a 0. Now I get my product and the sum so as to get the factors. So the product there is 100, this 10 here times that 10 there to have positive 100. Then the sum is that one there, the minus 25, and we get the factors as the negative 20 and negative 25. So when I substitute them there, I'll be having 10m squared minus the 20m minus the 5m plus the 10 is equal to 0. Then now I factorize the first two terms here and the last two terms on the left hand side. So the first two terms, the 10m is common. Then the next two terms, the minus 5 is common. Then also I factorize further since these two are the same. So the next step I'm going to be having into brackets 10 minus the 5 into m minus the 2 is equal to 0, just like that. Then either one part is equal to 0. So let's first solve that one. I take the minus 5 the other side of the equation to have 10m is equal to positive 5. I divide both sides by 10 to have m as 5 all over 10. When you reduce is 1 all over 2. Then I come back here that my m is the same as the log of x base 5. So I'm going to say my log of x base 5 is equal to a half, just like that. Then now I'm going to use the definition of logarithm, that the x is going to be equal to 5 power a half. Then when I take the power a half as the root, I'll be having my x as the root of 5. Now going back to get the answer of the other part, that one there, m minus the 2 to be equal to 0. Then I take this one the other side to become m as a positive, substitute the m as the log of x base 5. I'm having that. Then using the definition, the x is going to be equal to 5 power 2. So the 5 power 2, that one becomes the 25. When we go to part B, 3 log of b base 2 minus 6 log of 2 base p plus 7 is equal to 0. So even here we are seeing that these two logarithms that we have there in the equation, they don't have the same base. So we are going to make one to become the base of the other, and we are going to make the log of 2 base p to become log of p base 2 using the change of base. So when we change the base, we are having this here. Then we make the log of p base 2 to be an unknown. So we let n to be equal to log of p base 2. Then when we substitute the n, we are having 3n minus 6 all over n plus 7 is equal to 0. Then now we are going to multiply throughout by the n. So when we multiply throughout by the n, here it will be n squared, here the n will cancel out, here it will be 7n, there it will be 0 as here. Then we try to come up with the product sum and thereafter the factors. So the product, the 3 times the minus 6 to give us the negative 18, the positive 7 there, then the factors negative 2 and positive 9 there. So when I try to substitute those factors in the quadratic equation, I'm having 3n squared plus 9n minus 2n, there is n here missing, minus 6 is equal to 0. Now I factorize these two factors and also factorize those two factors there. The 3n is a factor here and there. So when I pull it out, here I remain with 1n, then a 3 there. Then the minus 2 to have n plus the 3 there. Then these two are also the same, those two brackets. So factorizing further, we shall have 3n minus 2 into n plus 3 is equal to 0. Then we begin from there, that one part is equal to 0. that is the 3n minus a 2 is equal to a 0. Taking the 2 the other side of the equation to become a positive, that is 3n is equal to the positive 2. Then the n will be equal to 2 all over 3 after dividing both sides by 3. Then bringing back the n as log of p base 2 right there. Then using the definition of logarithm, we are having p as 2 power 2 all over 3. So when we place the calculator there, we have that answer. Then we round it off to 4 decimal places to have our 1.5874. Then the other part, which is the n plus 3 is equal to a 0. We take the positive 3 the other side of the equation. Then we are having x is equal to negative 3. Then bringing back the value of n, which we said it is log of p base 2. Then we shall be having the p to be equal to 2 power negative 3. Then that one there, the 2 power negative 3 is the same as 1 all over 8. Then we have our exercise there. So try that exercise out, give me a feedback, share the link of the video, and then we grow more views.